Maximizing UPS battery lifespan, accurate checks. This document explores the critical aspects of UPS, uninterruptible power supply, battery health checks, emphasizing how diligent maintenance practices can dramatically extend the operational lifespan of these vital components. It aims to equip readers with the knowledge and techniques necessary to accurately assess and optimize the performance of their UPS batteries, ensuring reliable backup power when it's needed most. Understanding UPS battery fundamentals. Before diving into the specifics of battery health checks, it's crucial to understand the basics of UPS batteries. Most UPS systems utilize valve-regulated lead-acid (VRLA) batteries, known for their reliability and relatively low cost. However, VRLA batteries are susceptible to degradation over time due to factors like age. Batteries naturally degrade as they age, regardless of usage. Temperature. High temperatures accelerate battery degradation. Cycling. Frequent discharge and recharge cycles shorten battery life. Overcharging, undercharging. Improper charging practices damage batteries. Sulfation. Formation of lead sulfate crystals on the battery plates, reducing capacity. The importance of regular battery checks. Regular battery checks are essential for several reasons. Preventing unexpected failures. Identifying failing batteries before they cause a complete UPS shutdown. Extending battery lifespan. Implementing proactive maintenance based on assessment results. Ensuring system reliability, guaranteeing the UPS can provide backup power when needed. Reducing downtime. Minimizing disruptions caused by UPS failures. Cost savings. Avoiding costly replacements and downtime by optimizing battery performance. Methods for accurate UPS battery checks. Several methods can be employed to assess UPS battery health, ranging from simple visual inspections to sophisticated electronic testing. 1. Visual inspection. A visual inspection is the first line of defense in identifying potential battery problems. Look for the following. Bulging or swelling indicates internal pressure buildup, often due to overcharging or overheating. Cracks or leaks signifies damage to the battery casing, potentially leading to electrolyte leakage. Corrosion. Corrosion around the terminals can impede electrical conductivity. Cleanliness. Ensure the battery terminals and surrounding area are clean and free of dust and debris. 2. Voltage testing. Voltage testing provides a basic indication of battery charge level. Use a multimeter to measure the voltage across the battery terminals. Open circuit voltage. Measure the voltage with a battery disconnected from the UPS. A fully charged 12V battery should read around 12.8 to 13.0 volts. A significantly lower voltage indicates a discharged or failing battery. On-load voltage. Measure the voltage while the UPS is operating under load. A significant voltage drop under load suggests a weak battery. Note: voltage testing alone is not a definitive indicator of battery health, as a battery can maintain a reasonable voltage but still have significantly reduced capacity. 3. Impedance conductance testing. Impedance or conductance testing is a more sophisticated method that measures the internal resistance of the battery. This provides a better indication of battery health than voltage testing alone. Impedance measures the opposition to alternating current flow within the battery. Conductance measures the ease with which alternating current flows through the battery, the inverse of impedance. Higher impedance or lower conductance values indicate a degraded battery. Specialized battery analyzers are used to perform these tests. These analyzers typically compare the measured values to the manufacturer's specifications or historical data to determine battery health. 4. Capacity testing. Capacity testing is the most accurate method for determining battery health. It involves discharging the battery at a controlled rate and measuring the time it takes to reach a specified voltage cutoff. This provides a direct measurement of the battery's ability to deliver power. Procedure: disconnect the battery from the UPS and connect it to a battery load tester. Set the tester to discharge the battery at a specified current, typically the C/10 rate, where C is the battery's amp-hour capacity. Monitor the voltage and time until the battery reaches the cutoff voltage, typically 1.75 volts per cell. Analysis: Compare the measured discharge time to the battery's rated capacity. A significant reduction in discharge time indicates a degraded battery. Note: capacity testing can be time-consuming and requires specialized equipment. It is typically performed less frequently than other types of battery checks. 5. Temperature monitoring. Monitoring battery temperature is crucial for preventing premature degradation. High temperatures accelerate battery aging. Ideal temperature. The ideal operating temperature for VRLA batteries is around 20–25 degrees Celsius, 68–77 degrees Fahrenheit. Monitoring methods. Use temperature sensors to continuously monitor battery temperature. Some UPS systems have built-in temperature monitoring capabilities. Cooling. Ensure adequate ventilation around the UPS to prevent overheating. Consider using cooling fans or air conditioning in hot environments. Best practices for maximizing battery lifespan. In addition to regular battery checks, the following best practices can help maximize UPS battery lifespan. Proper charging. Ensure the UPS charging system is properly configured and functioning correctly. Avoid overcharging or undercharging the batteries. Temperature control. Maintain the batteries within the recommended temperature range. Avoid deep discharges. Minimize the frequency and depth of battery discharges. Regular maintenance. Clean battery terminals and connections regularly. Battery replacement. Replace batteries proactively based on age, performance, and manufacturer's recommendations. Typically, VRLA batteries should be replaced every 3 to 5 years. Record keeping. Maintain detailed records of battery checks, maintenance activities, and replacements. This helps track battery performance and identify potential problems early on. Interpreting test results and taking action. The results of battery checks should be carefully analyzed to determine the appropriate course of action. Healthy batteries. Continue regular monitoring and maintenance. Weak batteries. Increase the frequency of testing and consider replacing the batteries if performance continues to decline. Failing batteries. Replace the batteries immediately to prevent UPS failure. Conclusion. Accurate UPS battery checks are essential for ensuring the reliability and longevity of your UPS system. By implementing a comprehensive battery maintenance program that includes regular visual inspections, voltage testing, impedance conductance testing, capacity testing, and temperature monitoring, you can proactively identify and address potential battery problems, extend battery lifespan, and minimize the risk of unexpected UPS failures. Remember to follow best practices for battery maintenance and replace batteries proactively based on their age, performance, and manufacturer's recommendations. This will help you maximize the return on your UPS investment and ensure reliable backup power when you need it most.